Hello, hello, hello! Welcome everyone to the stream. It's been a while. I think maybe 6 weeks since I've streamed last. Trying to get back into the swing of things. How are you folks doing? If you are out there, let me know in the chat. I'd love to say hi. Today, we're going to be doing a couple of different things. First, I want to show you guys what's coming next for Retro Tank Party's next patch, the 1.1 patch, which I've been testing, in some periodic playtests lately. I'd love to do a playtest on stream as well. We're down to just getting the last bugs out, and then once we can get the bugs out, that will be released. And I wanted to talk about rollback network synchronization. And I will explain what that means once we get to it. I'm going to try and draw a bad diagram and hopefully make that more clear to folks who don't know what that is. So, Elliot's out there. Hey, Elliot. Let me get I'll get a match started in Retro Tank Party so I can give the match ID. And as folks start coming in, we can get connected. And then while we're waiting for folks to get connected, I will show a little bit of what's in the upcoming version of Retro Tank Party. So let me drop this match ID in chat. Elliot's watching on both Facebook and YouTube. This is my first time streaming on Facebook. I hope that it is okay. I went in there and just make sure that my countdown was running, but I've watched very few Facebook streams, so I don't really know how that all is supposed to work. But I'm happy that the chats are being synchronized. All right, so while we are waiting for anyone who wants to get connected and play a little playtest on stream, I should probably tell you how to get the game and all of that stuff, right? Like, that's useful information. So in the bottom of the screen, there is a bit.ly link to the web version of the game, which admittedly I haven't playtested a lot recently, but it should work with the beta version of the Steam game. So if you have the game in Steam, you're going to need to go to Properties, like right-click on this guy, go to Properties, go to Betas, and choose the Beta branch. I guess that's useful for you, Elliot, because I know you've been helping testing with the Alpha branch. I've moved everything to the Beta branch because that's synced with what's on the web version. But if you do not have the Steam version, you can go check out the web version, or if you want the Steam version, you can join the Discord, which is written below, and DM me, and I'll get you a Steam key, and then you can try out that version as well. So while we are waiting for Elliot or anyone else who wants to play on stream to get in there, I want to show you guys really quick some of the cool new stuff that is coming in the next version of Retro Tank Party, which I guess I did not open. Let me open a new instance of Godot and load that up. So we'll go into practice mode here, which has this nice debug menu, only in a debug build, so you can't use this to cheat or anything, to try out some of the new weapons. So new power-ups, I guess I should say. There's only one new weapon, which is this railgun, which has the ricocheting shot. It can look pretty cool, actually, if you shoot it between a couple of these boxes. And of course, you can hit yourself with it, which makes it a little bit dangerous to use, but it has such a long range that it's probably the most powerful weapon in the game currently. And there's also a bunch of non-weapon power-ups. We have this Zap power-up, which will teleport you to a random location on the map. A Boost power-up, which will send you flying forward for a second, probably less than a second, I don't remember exactly how long. And an Invisibility power-up, which turns your tank invisible to the other players, except when you shoot, you'll be momentarily visible, or when you get hit or pick up a power-up, you're also momentarily visible. I'll get another railgun. There's also another game mode added, but that's really hard for me to show you without connecting with other players. So maybe I can show that when we get to playtesting here. Has anyone jumped in? Elliot's jumped in. Awesome. Let me see how many other people are watching on YouTube. Not very many. So let's just give this a shot. Let's play a quick playtest here. I did do a bunch of bug fixes last night, most of them around deathmatch. So we'll do a short deathmatch and see how that goes. You also notice that in the new version there is a weapons timeout. So weapons can optionally only last a certain number of seconds, so you can't just pick up the spread or railgun early on in a match and then dominate. So let me find where Elliot's at. It's hiding. Oh. Tank's looking a little laggy right now, Elliot. I'm gonna zap out of here. Oh, didn't go very far. Let me get another power up. All right, there we go. Spread. Ooh, no, railgun. That's what I'm gonna go for here. Where is Elliot? Come on, we got to score some points since scoring was... Oh, teleported out of there. I'm going to take that spread before Elliot gets it. Ooh, no, he's got the railgun. See if I can sneak up on him because he won't expect me to be on this side. No, that didn't work. No. Just refilled my zaps. Ooh, why did I teleport? I was right in there. Should have hit you. Ooh, and his railgun timed out, so that's a nice test of... Ooh. Alright, so Elliot's got one on the board. I gotta score another point quick. Oh, no! Dude, you are getting seriously good power-ups. Railgun and zap 2 times in a row. He won't expect this. Not that he's watching my screen on stream. Haha. Hopefully with the 10-second delay, my invisibility was helpful there. Aha, Tracer. Oh, I gotta get another point. Gotta get him down before... Okay, I might win this. Actually, I probably will. 15 seconds left. Eee! You should take... Yeah, take that railgun. Did I really get 3? Oh, okay, cool. For some reason, I thought I was only going to win with 2. All right, so scoring didn't explode. The game didn't crash. It's also good. Oh, and something else new that was added that we can't test without some more people in here. Let me see if anyone else is viewing on YouTube. No. Is team-based matches. I guess we'll do football for a second because that's team-based. Or maybe 2 minutes is not quite long enough. I don't know, 3 minutes. So this is the new game mode. The football game mode. Oh, Elliot, you still with me? We playing? Either there's a problem or Elliot had to step away. All right. Are we playing? Eat. No, why aren't you shooting me? 2 easy points, man. Gotta put up a fight. Oop. I don't think I have the sound for this coming through on stream, so you're missing out on that really awesome horn. I think I just turned on the sound. Recording in OBS, we'll see. Don't want to get too close to him because if he starts coming this way, I want those tracers though. Out of bounds. Beep. No. Uh-oh. As soon as I'm in, I'm going backwards. All right. Woo. Stopped him. With just 2 players, this game is actually like really hard to if someone starts making a breakaway, there's just no way to catch up. I hope you guys got to hear the horn on that one. Oh, but I wanted to get the ball and use my zap. I wanted to zap my way into the goal. Ooh, okay. Ooh, invisible to the goal? Haha, I can't see me. Don't know where I am. Oh! No one expects the invisible Inquisition. Alright. We need to get some more players in here. This is... Oh, yeah, railgun. Come on, where are you? You're over here somewhere. Come on! Yeah! Did I knock it out of bounds? Wow, okay. Whoop. Oh, no, no, no! Let's get over! 30 seconds. Well, I'm way in the lead. Ooh, what happened there? That was definitely a bug. Haha. See if I can make a run for it. No! 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 Oh, come on! Ah! Ah! One last point. One last point to end things off. Oh, come on. Yeah, so I don't know if you guys noticed, I hit him twice, according to my screen, but it didn't knock the ball out of his hands, which is a network synchronization problem, and we're going to be doing network synchronization stuff. Anyone else watching? Anyone else want to get in on this? If there's anyone else who wants to join the game and play with us, let me know. Otherwise, I think I'm going to stop it for now. I definitely would love to do more playtesting with more players. I think that's good for the moment, though, unless anyone else can jump in. All right, so network synchronization. Speaking broadly, that's basically trying to make sure that the thing I'm seeing on my screen when we're playing a network game together is the same thing that you're seeing on your screen. And it never is. The fact that you think it is and that it seems close enough is an illusion. Yeah. So Elliot saw some hits that should have registered on his end. So yeah, more network synchronization problems. So in this particular case, I'm seeing on my screen that I'm hitting him with bullets, but the game's not reacting as if I'm hitting him with my bullets, and vice versa for him. And it's never perfect. In no game is it ever perfect. You're trying to get it close enough and trying to make it so the areas where it's wrong are either not terribly noticeable or still fun. Like, if it can be a little bit wrong, but the game can still be fun, then that's fine. And the reason I started thinking about this a lot lately is that in the football mode that I just added, these same network synchronization problems that have existed always and have never really messed with the fun very much are now super noticeable and kind of messing with the fun. So I started thinking about more advanced network synchronization options. I'm glad you still had fun, man. I still had fun too. I was having a lot of fun. So I started thinking about more advanced network synchronization options, one being rollback, which we're going to talk about. Let me drink some tea really quick, and then I'll draw a picture. So we're going to say we have 2 players. Whoop, need the pencil here. We have player 1. Wow, I write terrible with a mouse. And player 2. And we're going to say we both start the game at the exact same time, and then a number of frames take place. Frame 1, frame 2, frame 3, frame 4, frame 5. And the same on the other player. And let's imagine that there is a 2-frame lag between these 2 players. And 2 frames isn't bad. That would be 32 milliseconds. So 32 milliseconds of latency is decent latency. I've definitely played network games with more latency than that and had them been fine. Which would mean that when the game first starts, player 1 will imagine some inputs here. We'll say up, up, down. So on the first frame, I'm pressing up. On the second frame, I'm pressing up. On the third frame, I'm pressing down. This is too short, going just a frame. But if we drew, 60 frames, that would be too hard for us to understand. And then over on this side, we haven't gotten this up input yet. So on player 1's side, it still doesn't look like I've moved up until finally by frame 3, because there's this 2-frame lag, player 2 now sees this input from player 1. So there's this 2-frame lag where player 1 is doing stuff, but player 2 doesn't see it yet, and the same from the other way around. So player 2 will be doing something, but player 1 won't know about it until 2 frames later. So you're basically always kind of seeing the other players slightly in the past, and how far in the past depends on the latency. And there's a bunch of different ways to try and fix this to make things closer. One of them is just injecting some kind of delay. You can delay your own inputs by 2 frames. So then we would have, if we added a 2-frame delay, then player 1 would be pressing up, up, down on these 3 frames, but the up wouldn't actually take place until the 3rd frame. So then this up would only take place on player 1's machine on the 3rd frame, which would be exactly when player 2 also saw that same up. And this works okay, but the latency, of course, varies, so it won't always be a 2-frame lag. So then, how do you decide to adjust the size of your input delay? Another problem is that you can only add so much input delay before the game really starts to feel laggy and not very fun to control. And also, this being a peer-to-peer game, we're using WebRTC, making kind of a peer-to-peer mesh network. Knowing what the lag is between all of the different clients, really can't tell you what your local input lag should be. Let's say my lag to Elliot is 2 frames, but my lag to somebody else is 4 frames. Well, how much should I delay my input? So that's kind of a fraught method, but it's very simple to implement. So a lot of games use it. There's a bunch of other techniques that can be used when you're doing a game with an authoritative server. So you're still going to deal with the issue of the inputs being delayed with an authoritative server. In fact, they'll actually be delayed even longer because the inputs have to go to the server and then back out to the players. And also the server usually doesn't send out inputs immediately. It's like gathering them up and then sending out kind of a summary of all the inputs periodically so that it can, maybe get all the players' inputs in a single message. But in that case, what you can do is that in cases where the lag will be noticeable, like, for example, shooting the other player, one of the peers can say when they shot when they shot their bullet or whatever, and where they were pointing and all of that, and the server can rewind time a little bit and say, okay, I know what you were seeing at that time because I can rewind everyone's information to this point, and then I'm going to do the shot calculation based on the time in the past, and then decide whether it was a hit or not based on this rewinded time. But it doesn't actually synchronize anything. You're still going to be seeing everything some frames off. It does make it a little bit simpler, though, to do things like interpolation and extrapolation, where you're kind of guessing, where all of the different players are, because you're only dealing with one source of input. Anyway, we're not talking about any of those techniques. There's one technique that has always been very attractive to me because it's theoretically makes it as close as possible on everyone's machines that you're seeing the same thing, and that's rollback networking. And the way that works is that you still have this delay of when your inputs arrive. Let me delete some of my junk on here so I can make this a little bit easier to illustrate. You still have this delay, but when your input arrives, you'll say your frame 1 will arrive to player 2 on frame 3, but it's marked as being for frame 1. So then it will actually rewind time on the client, inject this input here on frame 1 where it was supposed to be, and then play time forward again. And that will, you will still maybe not see these 2 frames as they are happening, but when you got to frame 3, you would see the correct result of that input happening back on frame 1. So you're not seeing people in the past necessarily. You're maybe just seeing a a choppy version of what the present should look like, right? Because between these two periods of time, so let's say this arrived on frame 3, and then it's playing time forward again. It's going to guess what you were pressing on frame 2, which is probably the same thing as you were pressing on frame 1, and then getting to frame 3 and using player 2's input. Wow, I feel like my explanation of this could be so much better than it is. Is that making any kind of sense about how rollback networking is supposed to work? I almost feel like I should just start over, just scrap this and go back to the beginning, trying to explain it. It also earlier I was talking about how certain types of network synchronization were problematic for peer-to-peer. This actually works great for peer-to-peer because let's say we have a third player. It doesn't matter if the lag for the third player is 3 frames instead of 2 frames. Whenever we finally get their input, we just roll the state of the game back to where it was that input was from, inject it, and roll it forward. And then if later we get different players, player 2's inputs for the frame after or the frame before or whatever, we can still roll back, inject it, and roll forward. So it's a really powerful network synchronization technique that gets things super close, but it's actually very difficult to implement. And I've been experimenting with implementing it. I put a quick YouTube video up last week Friday where I was trying to solve a problem that I did actually solve with implementing this technique, and that was the problem of how do you know that my frame 1 is the same as your frame 1? Thanks, Elliot. I'm glad that it's making some kind of sense. So if you're going to be sending a message that says, hey, on frame 3, I pressed up, my frame 3 has to be the same as your frame 3. Otherwise, all of this just turns into nonsense. And I did end up figuring out how to do that. I made a little demo, which I can show you. But I'll sort of talk through how this works. Part of making sure that my frame 3 is the same as your frame 3 is just through the force of saying that it is, right? Like if we both start the game at roughly the same time, and I'm saying on my frame 3 I pressed up, and then you receive that message and you go, okay, rewind the input buffer and put an up for this player on frame 3, and we keep doing that through the whole time. My frame 3, and the other way around, you're sending me your frame 3 with you're pressing down or whatever. After we've both sent both of our messages, my frame 3 will say I pressed up and you pressed down, and your frame 3 will say you pressed up and I pressed down. Like they will be synchronized because we are synchronizing them. But there's still a couple of problems there. One is what happens if we get way too far out of sync. Like this method depends on every frame. We're basically saving a state of the game, saving the game state, so that when we need to roll back, we can say, okay, I have 20 frames of game state. I need to roll back 3 frames. I'll go backwards 3 frames and then start rolling forward. So one problem is if we're not totally synchronized on whose frame 3 is my frame 3, we could end up needing to go back further than however big our buffer is. Like if we're saving 20 frames of game state and you're telling me you have the input from 21 frames ago, I don't know what to do with that. So they need to stay roughly synchronized. And the other problem is if I'm always 2 frames ahead of you, that means that I will always be predicting 2 frames of your input, but you will not be predicting my input because you've already got it, like I already sent it earlier. And so the game ends up being unfair for whichever player's computer is running ahead, and it ends up being the worst experience for whoever's playing ahead, because you'll see the most artifacts of the corrections when the rollback and roll forward comes in. There will be a little jump, right? Like I predicted that your tank was going to be 2 pixels this way, but in fact it's 2 pixels that way, and so there will be this spontaneous 4-pixel jump, and whoever is predicting ahead will see more of those. Anyway, so there's this problem of trying to make sure that in the real world, if you were to somehow have these computers sitting next to each other, my frame 1 would occur at roughly the same real-world time as your frame 1, and so on. And even if like your computer slowed down a little bit, or there was like some network lag or whatever, we need to try and make sure that these frames are occurring at roughly the same real-world time. And there is a technique to do that, which I implemented last week in a little test project. Let me get that up. Rollback networking test. So the way that this works, and this is done with a client server whatever connection, which is fine. I'm imagining that it would be done in a peer-to-peer networking situation, but for the purposes of this test, like there's 2 computers connected, they are peers. It's fine. So we'll say one is the client, one is the server. Basically, if one of the clients detects that the other is getting behind, it will skip a frame or multiple frames, however many frames it needs to skip on its end to allow the other client to catch up. And it does this with very little information, and it's super cool. It basically has, we get, what is it? We're sending in each of our messages to the other players. Let me find the code for that. Where the heck is this message? Oh, here we go. So we're sending our current tick and the next tick that we're expecting to get from the other peer. And that allows us to calculate how far ahead or behind we are from them when we finally receive a tick from them. Because when we receive a tick from them, we're also getting what their current tick is and the next tick they expect from us. So we're able to take the last tick we receive from them minus the next one we're expecting to get, and that will tell us how many frames the other client is predicting for us. And then we're able to calculate the reverse also, but we're calculating that, it looks like at the time that we are actually rendering the frame. But that's basically taking our current tick minus the last remote tick that we received from that player. Anyway, so we're able to see if they are predicting more frames than us, which will tell us how many frames they are ahead, which will tell us how many frames we need to skip, which has like some really cool properties. You can see only one skip was needed here because like I'm on the same machine, so obviously these are going to run pretty much in lockstep. On my video that I did 2 weeks ago, I was introducing some latency and some lag, and you could see it skipping more ticks. I don't think I'm going to mess around with that. I want to get down to actually like writing some code today. But by skipping these frames, we're ensuring a couple of things. We're ensuring that one player doesn't have an advantage by being slightly behind the other players and hence not having to predict so much. But we're also like indirectly making sure that the frame ticks are happening at roughly the same real world time on both computers, which is super cool. There are a lot more problems to solve for rollback network synchronization, but it was super cool that this one turned out to actually be so easy. Just by sending our current tick and the next tick that we expect from that peer, we're able to calculate if they are ahead or not, and then skip a frame. Oh, and another cool property of this, I'm only showing 2 peers in my little test here, but this technique works perfectly with an arbitrary number of peers also, because if you detect that one of the peers is a certain amount behind you, so you skip a frame, then all of the other peers are going to suddenly detect that you are now ahead of them, so they will also skip a frame. So without communicating with each other at all of the peers will sort of like skip frames in lockstep to align themselves up with whoever the slowest peer is, which is just super cool. Like passing very little information, they're all able to stay synchronized without needing to communicate additionally about what to do. So anyway, I hope some of that makes some kind of sense. Explaining it to my webcam and not being able to see people's faces, it makes it very hard for me to tell if I'm making sense or not. All right, so that is an overview of what rollback network synchronization is. That was the stuff I figured out with synchronizing last week. And then what I want to work on today is trying to implement the rest of rollback network synchronization in this tiny demo. So let me just, no, wrong thing. Let me just make sure what branch I'm on. Okay, so I'm on my rollback branch. I'm just going to switch to the normal branch so I can just show you how this is supposed to work. So here is a little demo application. It uses a asset that I made for the Godot asset library, where I guess I have to start up 2 clients to show this. Hang on, I can't do things and talk and think at the same time. I'm not that smart. All right. So the asset is for setting up WebRTC connections using Nakama as a signaling server, which RetroTank Party does. And you know, it's setting up WebRTC can be tricky because you need this extra signaling server to be able to help all of the different peers find each other. Nakama is cool. You can drop in this asset and it will take care of like really all of the work of being a signaling server and getting connected. But the actual game here is crazy simple. Here, I have to change my keyboard mapping to. Okay, I will actually change my keyboard mapping. Set XKP map US. Okay, that's better. So it's a super simple demo. Each client just gets this little Godot icon they can move around. And if you press the spacebar, it's the attack. So I can bring one of my little Godot heads over here and attack the other, and then I win. Nothing fancy, and that is why I would like to use it for trying to implement rollback networking. Getting this, actually taking whatever we figure out here, whatever rollback networking technique, and implementing it in RetroTank Party, which would be like ultimately what I would want to do someday, maybe if this works and doesn't seem too insane, would be a lot more work than what we're doing here, because a lot of things you would do in a game that doesn't do rollback, you'd have to change. Like you can no longer use timers based on time. You have to do all of your timers based on counting frames. All of your animations can't be done on time. They have to be on frames. So many changes. But let's see what we can do in a super simple example today. All right. And I started on this a little bit last week. So let me bring up what I've got and show it to you. All right, so where was I even doing this work? Sync Manager, that's the thing. Okay, so I started making this Sync Manager. It's basically, I started with the code that I had for my little demo that was just syncing up the frame numbers. So it's doing the same kind of tracking, like it's recording the last remote tick received, the next local tick that client is requesting from us, calculating the lag. The advantage is basically the difference between the local and remote lag, just kind of averaged over how many frames? Over a number of frames. Ticks to calculate advantage. Ticks to calculate advantage is where? Ticks to calculate advantage. Okay, 60 frames. So every 60 frames, we are calculating the average advantage and then using that to decide if we should skip a frame or not. Can this really like refer to a variable in the outer class like that? Oh, it's being passed in as an argument. Okay, that makes sense. That makes sense. Just trying to understand my own code. Sorry. And I started adding like the infrastructure for actually doing the rollback and stuff. So let me show you how that is supposed to work. Yeah, so rather than having the objects that are going to be synchronized use physics process like you normally would to do something on the physics tick, we're going to be using this network process. I guess I'll point at this one. Rather than physics process, so that we can either call it or not call it when we're skipping a frame, and so that we can call it multiple times within a single frame when we're doing like a rollback and play forward. And any node that wants to get its network process function called needs to add itself to a network sync group. We're going to save and load the state of these network sync nodes by calling a special _save state and _load state method, again on nodes that have put themselves in the group of network sync. So any nodes that want to be synchronized need to add that group, implement those methods, and then in our sync manager here, in its physics process, we are going to decide whether or not we're going to roll back. So every time a physics tick happens, we're going to say, hey, are we supposed to be rolling back some number of ticks? And if we are, it will try and load the state that we have stored from that many ticks ago. It will remove all of the state after, remove all the input after. Is that right? I think this code might be bad thinking here. I'll add a little to-do for myself. I think we don't. I think we very decidedly do not want to remove future input. We want to modify the old input, but we might have some input later in there that we want to keep. We'll come back to that. Let's just get through the overall picture here. And then for the number of ticks that we're rolling back, we roll forward. Yay! If there's any ticks we are supposed to skip, this comes from calculating that advantage. We'll skip a bunch of ticks here, and then we're calculating the advantage and deciding whether we're going to skip some ticks there. If we get past all of that, we're going on to the next normal tick. So we're incrementing this tick. A to-do. Don't have the code for it yet. We'll be writing that soon, I expect. We'll gather whatever the local input is and put it in the input buffer. We will loop through all the peers we are connected to, send them a message that contains the same information from the other demo, the current tick and the next tick requested, but also the local input once we actually have it. And then finally actually execute the normal current tick locally. And I hope that makes sense. Does that make sense? If anyone's still watching, if anyone's stuck through all of that bad explanation, does this make sense? Does anyone have any questions? Anything? I feel like you know, I just want to do these streams, like go on a stream, show some stuff, hang out. But I kind of feel like sometimes I'm doing things so advanced I should have like a presentation made in advance to like explain what the heck is happening before I do it. So I'm really sorry about that. Sweet, Damon. I'm glad that it's making sense to you. Thanks for checking out the stream. I think the first thing that we need to do to take this to the next level, to actually have this work, is start collecting state. To start having the, I guess in this game it would be those little Godot heads, which are in the scene, to start having them save their state. So that we can put it in the state buffer and reload it later. And maybe we'll do like some test where we'll like tell the game that it always needs to roll back 2 frames and like re-roll the state forward 2 frames or something, just so we can test that it's working. So let's do that. We'll open up the, not add-ons, actors. We'll open up the player scene, our little Godot head here. And we'll start by adding this player to the network sync group. Yeah, hopefully Elliot seeing it in action will make some sense. In the end, like once I figure this out, if I figure it out, I hope I figure it out, I will make some kind of presentation on how this is implemented and how it works. But I expect that I will screw up like a dozen times before I get it working. All right, so this is now in the group, and we have this physics process here, which we're going to need to change from physics process to network process. I think I still have us passing a delta in for network process, even though that does not make sense at all to pass in a delta. Or I guess it kind of makes sense in the sense that you might still want to do your movement calculations based on however long your tick is supposed to be. even if it's not actually that long in this particular instance, like if we're rolling back and rolling forward all at once. So I guess it's fine. Let me just go make sure the sync manager is still passing that. Yeah, it is still passing delta. But yeah, as my to-do, past me has noted, it probably makes more sense to pass the input frame that we were on, and then maybe have somewhere globally accessible, like how long the tick is supposed to be. Hey, Thomas. Yes, my actual game is more than 1v1, and actually I think this demo too. This demo you can play up to 4-player. But the ultimate place that I want to include this network synchronization technique, if we can get it to work, is in Retro Tank Party, which is up to 4-player. You can either be every person for themselves, 4-player, or in teams, where you could be 2v2 or 1v3 or something like that. Now that there's more people here, guys, if you want to playtest Retro Tank Party on stream, like for a couple of minutes, I would love to do that. Just let me know in the chat if you guys feel like playtesting Retro Tank Party. We can take a break from my big epic winding nonsensical explanations. And if you wanted to do that, you can get the you can get the web version on the bottom. But yeah, Thomas, GGPO. So GGPO is implementing basically exactly the network synchronization technique that I'm talking about here. And I agree that it can't work with too many players. I think that 4 players it will work though. I guess only time will tell to actually implement it. I mean, you can't do like a massively multiplayer game, but yeah. So more players equals more possible states, meaning more jerkiness. The more that you roll back, the more jerkiness there will be. I don't think you're necessarily going to roll back more because of more players. You'll roll back more if you're doing more prediction. The more prediction that's inaccurate that you're doing, the more you'll be rolling back. So if the players are like really out of sync, then you'll be doing more prediction. So I guess if one player is just always falling behind, no matter how much you go and wait for them, that will yield more jerkiness, and there's more likelihood that such a player will exist in a bigger match. But yeah, I think it can work. I think it can work for a 4-player game. We'll see. Thomas, when you were testing it, how many players were you working with in GGPO? Cool. Yeah. With every game will be different, so I wouldn't necessarily just say like, okay, these games work badly with 4 players, so like every game will work badly with 4 players. But that is interesting. I will have to go check out Fightcade and kind of see how the implementation works there. I would also say that I think if your prediction is really, really good and you're predicting very infrequently, or your predictions are wrong very infrequently, that I think you would lead to less jerkiness. And in Retro Tank Party, there is no gravity or actual like physics. It's yeah. So in Fightcade though, if one player is lagging, all 4 will. Yeah. If so, ideally, the other clients will slow down to make sure that that 4th player is in sync with them. If they keep having to do that, though, then it will get laggy, because then you're skipping frames very, very often. I don't necessarily know that a different network sync technique, though, would be better there. Like, if you were doing, instead of peer-to-peer and rollback, if you were doing like server authoritative, let's think through this. And one player was really slow, we would be receiving that player's inputs hyper delayed. And so they would be getting corrected with, you know, not rollback, but I guess reconciled is the proper term. They'd be getting reconciled with like interpolation or just like straight up dead reckoning the most. So you would see that one player be super jerky because there's nothing we can do about them having bad latency. The other players, though, I guess wouldn't be waiting for them. They would just keep plowing forward. So maybe that does create a better experience for the players who are not lagging. I guess it depends too, like how are you reconciling the different things in the game that score points, right? If that player who is super slow is able to somehow take advantage of their slowness, I don't know. It's hard to say. It's hard to say. I think it's worth trying this, and then we will see. We will see. All right, so where was I in the code here? So I was changing the player to use network process instead of physics process. We are going to have to not get the input from the input singleton. We're going to have to get the input buffer, but we're not doing any. The input buffer is totally unimplemented so far, so we're going to not worry about that now. We do not want to be sending these updates because we're going to let the sync manager just send inputs. In the interim, do we want to send them though? Maybe we do. Maybe we do. We'll just leave all this the same, but we'll switch to network process. And we're going to focus right now on saving the state and loading the state. And I think this is meant to return a dictionary. Let me double check that in a second. Call load state, it's grabbing it from, I guess it's not defined, but I think it was meant to be a dictionary. So it's gathering up the state into, I guess, its own dictionary based on the node path, and then getting a dictionary of state. Okay, so what state do we need to save for a player? We need the player's position and whether we are attacking or not, I think. I think that might be it. Where is this is attacking coming from? Okay, so this is a local variable. Okay, so I guess I see why it's doing it like this for the way it was working before. We kind of need to know if we are attacking, like what frame we are on this attack so that we can rewind there. Can we get the animation player to tell us? Here, let's go look at animation player. Animation player. What I want to know is if it can tell us if it's playing, and okay, so is playing a method, and I want to know what exact position it's on. Can we know that? Current animation position. Okay, okay. So this is a bad idea long term because we don't want to do things based on time. But for now, just to get things going, we're going to do position equals, I guess we'll do global position. I guess it can be normal position. So we'll store the position in the state. We'll say animation player is playing. Animation player is playing. And animation player current position. I think that's what the current animation position. Do we need to know which animation it is? Like, do we have multiple animations? Nope, only attack. I guess maybe we should store that. Animation player, current animation player, current animation. And let's put that in this order. Okay, so that could be what we need to represent for the state of a player. And when we need to restore that state, we're going to do position equals state position. Grab that out of there. The animation player. Okay, so if the animation player, if we rewind and it's not playing, we need to start it. Should we always stop it? I think maybe we should always stop the animation player and then say if state animation player is playing, then we'll do animation player play state animation player animation. And then we're going to jump the current animation position to, can we do that though? Current animation position, it only has a getter. How do we fast forward? Animation get next. Seek, here we go, seek. See what that update is from. Seeks the animation to the seconds point. If update is true, the animation updates too. Otherwise, it updates at process time. Events between the current frame and seconds are skipped. Okay, so that's cool. We will do the update, I think. We play, and then we seek to animation player current position, and we pass this update argument as true. All right, I think that's enough to save and load the state for a player. And let's take one last look at Sync Manager to see if enough is implemented here for this to theoretically actually work. Where are we capturing the state? Do tick, maybe do tick, do tick. We call network process, and we append call save state. Okay, so that should start saving our states. Thomas says he thinks that I want the advanced function instead of seek. Seeks position and animation timeline immediately updates the animation. Shift. It's between the current frame and delta handle. Maybe. Let me check that out. Advance. Events between the current frame and delta are handled. I don't think we want events between the current frame and delta to be handled, though. Because we've stopped the animation player, so now it's at the beginning of the animation, and we want to just jump to whatever seconds into it without those things earlier, or we want just the last earlier thing to happen, right? I'm not sure. I am not sure. The sequel skip events if you're calling functions the animation like I was spawning projectiles and such. Yeah, so like we want the frame to change to whatever the most recent thing is, but we don't necessarily want all of the things to happen. Like on this timeline, we're calling a function, we're calling a tag. And if we jumped to say here, we would not want a tag to happen. when we restored this state. We would want this modulate and this scale to be at the point they are here, but we would definitely not want this function to happen. Yeah. So I mean, we are calling a function. We're calling this attack because we have the attack take place at the 0.03 second of this animation. But if we were restoring state to 0.05, we would not want this function to be called. I'm gonna put a note about advance in here, Thomas. Where the heck even was that? That was in player? And we're going to try it with seek. And that seems like it would eat the player's inputs, like the person press attack. Well, so the restoring a state is just trying to get us back to the position we were at. Like if we saved state when we were here, we'd want to get back to exactly here. The attack would already have happened. We don't want to call attack twice. If we rolled back to here, we would want to attack. But if we were rolling back to this spot, we would not want to attack again because the last time it called attack is still in effect. Because we're not rolling back past that. Like let's say we had gotten up to here. This is where we decided to roll back, and we decided to roll back to this spot. Then this attack happened. It went. And if we were to do it again, then we would attack twice. In any case, I think we should try this with seek and see what happens, and then if it doesn't, we can try advance and then compare the result. So I'll put a little note here that it was from you, Thomas. And let's see if we can get some things running. Once things are running, then we can look at them more objectively and compare them against our expectations. All right, so back to the sync manager. I just want to make sure that we're saving state correctly. This kind of looks like we're saving state forever, which I don't know that we want to save state forever. We want to only keep a certain amount of state. So let's add a variable max state count. Okay. And so then we need to say if state buffer size is greater than max state count, then we'll do state buffer pop front. Not if, because we don't know how many we have to go. So if while size is greater than state count, pop the front of the buffer. So that should be good. Let's just make sure this doesn't explode. And if I do local, will it run this stuff anyway? Ooh, that's interesting. Well, that's totally broken. These are all slightly red. Oh, you know, it's slightly red because I left that animation halfway. Okay, so we can fix that pretty easy. Animation player. So we'll just put that back to the beginning. That's fixed. This being totally stuck is interesting. Let me look at that code I just wrote. I just have a bad feeling about that code I just wrote. Size is greater than max state. No, that's fine. All right, let's see. I'm gonna just quick look at git diff between the normal branch and this branch and see what code outside of the sync manager I did. Nothing outside of the sync manager. Oh, okay, so I bet what's happening is that our network process isn't getting called. So let's set a breakpoint and go check that out. No, nothing's happening. It's not even breaking. Sync manager. Is it because the sync manager isn't instantiated? That seems like a likely culprit. All right, let's find the game scene. Where is it? Game. And we need to instantiate our sync manager. Or is it just a script? It's just a script. Okay. So, I guess what we're going to do is we're going to add a node, plain ass node, or is it a node? No, this one's a node 2D sync manager. It's a plain node. I guess we'll do class name sync manager, and here we go. No, this one. I feel like I should be able to add that in one of these menus, but whatever. We'll attach it this way. Sync manager. All right, now we hit a breakpoint. So let me unbreak point and just see what happens. Okay, so we are still not working. Let's reset our breakpoint. Why isn't it breaking again? It should break again, right? Or maybe it did just really fast. Step over. All right, we are, if not started. Okay, so we're never calling start. That is good to know. So we'll do onReady var sync manager equals sync manager and game start sync manager start. All right. Get rid of this breakpoint. Okay. So this is expecting that we are always running in network mode. Okay, that's fine. That's fine. We will switch this up. And I guess no, we don't actually want to do this here. This do game setup is where we want to do it because the sync manager needs to run everywhere. We're going to first pause the game, stop everything, reload the map, game start, do game start, and then right here is where we want to start the sync manager. And now, since it needs to be in the networked mode, we'll start up 2 clients. And we got an error, all right. Invalid call to network process. As method, network process, network process. What am I getting wrong here? Process. Oh, expected 1 argument, and I'm passing in, okay, cool, cool. Player, network process, sync manager. Will that fix it? I guess I have to kill it, start over. All right. We're closer. Aha! Okay, so our network process is being called, and ooh, look at how choppy that is. I don't know if you guys can see that on the stream. But it's like super choppy. That's interesting. It's like very little has changed between the original version, but super choppy. Okay, let's see what we can do to test what is happening. I guess I want to see the state. I don't want to print out the whole buffer of states. Maybe just print out the last bit of state. Which we had here. Okay. Let's just see what this looks like. Godot has thwarted me again. Too much printing. All right, but this at least lets me see current position 1? That seems interesting. False, current position 1. I guess if, okay, so if it's 1 second long, it would always end on 1. So that sort of makes sense. Saying root game players 1. Why do we only have one player, not the other player? Oh no, here we go. I see the other player. Players 2. So current animation. It seems like it's recording state accurately. We need a better test. What can we do? What can we do to really screw with the system? Since we don't have the input buffer stuff, we can't really force it to roll back and roll forward a bunch every frame, which I really want to do. I think that would be a really good test. Maybe I guess we have to figure out input buffers first. Let me commit what we've got so far to Git, so I can kind of keep track of all the changes. Yeah, that all seems good. Okay, so add sync manager to game and start recording state. All right. And then we need to have an input buffer. So how was I thinking we were going to do this input buffer? I had a plan. I did, I swear. I think my plan either involved having like a child class of the sync manager that would be responsible for gathering input, and you just like implement a virtual method. Or I had another idea where like the network sync nodes were responsible for gathering the input that they needed, which would also be really nice. Just trying to see if I made any notes about that for myself. If not, we'll just have to figure it out on stream. I think the easiest thing to do though would be to just make like a child class. Then we don't have to. I think it would be better if the nodes were responsible for deciding what their input was, but simpler to implement to make a child class. So what we are going to do is add the empty virtual methods here. I'm just making sure that I haven't added them already. Nope, doesn't look like it. And we'll put them, I guess, near where we're going to use them, which would be the tick. Yeah, we'll put them around here. This would be, from my notes, I was thinking gather local input, which will have return a dictionary. Dictionary is a very inefficient data structure to use for this, especially because we're going to be passing it over the network. But it is the simplest for us in prototyping. Dict input, and then we're going to take, I guess this would be like previous input, and we're going to return a new dictionary of input. And by default, we're just going to do previous input duplicate. All right. that seems fine. I'm actually going to remove this class name because now that I'm doing this and we're doing these subclasses, I'm kind of realizing that I don't want that to be in the class DB. So then here we're going to do extend script. Now we have our child class of sync manager, and we are going to do gather local input dictionary, and we're going to get the same stuff we're doing in player here, this vector and action just pressed. So I'm just gonna copy and paste this, and then we'll edit it up in this script, which I guess we should save this. Ah, where did it save it to? Where? Oh, okay, I guess we have a sync manager here. Okay, I don't like that name though. Let's rename this. So we'll say game sync manager, something like that, to distinguish it from the parent class. And is this still connected? That one's still connected. Good. All right, so gather local input. Let me just throw this here. So do we consider the individual button presses the input, or do we consider the resulting vector the input? I think in most games I would probably want the individual button presses, but in this game, because it's a 2D top-down thing, I think we just can summarize that up to the vector, and I think that's fine. So we'll say input vector. Why is it mad at me? Oh, because of this. Input vector. Or maybe it'll be easier to read if I do actually put that. Hang on. Yeah, okay, I'll say input vector. An input prefix. It needs to know what player it is, because there's a local version of this. How to reconcile this with the local play thing. So we need to know who we are gathering input for, I guess. Gather local input, which I guess would be like player index. Change that over here. Where the heck is that code? There it is. Player index. And yeah, it's going to be mad at me because we're not actually using the variable. Okay, and then input prefix is basically a different way of realizing that player index. So it's player. Or you know what? I can reuse all this code. Just doing var input prefix player index. Okay. All right, so the first part of the input is this input vector, and whether or not they are attacking. And when I was doing input prediction in Fish Game, I did a thing where for anything we were checking for just pressed, we would predict that the next frame we were not just pressing it anymore. But I don't know if that's the right thing to do in this case. So we'll say attack pressed, it's just pressed. I think it is the right thing to predict because Godot will always unset something that was just pressed. So we'll roll with that. So we'll do predict. What did we call that method? Predict input based on the previous input. Okay. Okay, but we're going to always reset attack pressed to false and return that. All right. So we are gathering our input. We are predicting our input. Let's first just modify our code to pass. No, we have to first start by gathering the input in the input buffer, where do we do that? I guess here, gather local input. So our local input equals gather local input. And I guess I need to know what my local player is. Man, I did not take into account the fact that this game allows local play as well as remote play. What is the right answer here? I guess I could just... Well, no, because local play will never touch this class. So we can make some assumptions here. So online match, get... let's go look at online match really quick. I don't remember the methods on it. So what we want to know is which player we are, so that we can request... Wait, we're always player 1 in remote play. Okay, so we're good. We're good. Get local input 1. We can make that assumption. We can make that assumption. So we've got the local input. We need to send it. We need to add it to the buffer. Okay, so in rollback, we already have everything in the buffer. I'm just trying to think of how to make this do tick function generic between when we're rolling forward and when we're rolling back. Maybe I'll just ignore rollback for now, and come back to that when we're actually implementing rollback. So do tick, we need to pass the local input, or at least it needs the local input. I'm debating whether we need to fill up the input buffer first and then let do tick grab the data from the input buffer or pass the data to it. For now, I'm just going to pass the data. If that turns out to be the wrong decision, we'll come back to it later. Local input. And call network process. We need to pass into network process the input. In fact, we need all of the input. Right? Not just this player? So how do we know which input a particular is destined for a particular player? We need to figure out that. All right, let's come back to the top here. So we have peers. We probably need some kind of input buffer frame class, because what do we need to know for each frame on the input buffer? We need to have the input for each of the players. How do we identify the players? I guess by their peer ID? So that would be a dictionary. And we need to know whose input is predicted and whose isn't predicted. How do we know that? Or how do we record that, I guess is the question. We don't really want to do another dictionary, right? Because that's kind of sloppy. So, okay. Buffer frame, input buffer. Input for player. And then we just need to know predicted. And then our input buffer frame would be like a collection of those input for players. Something like that. So we'd have an input for player for each of the players, input buffer frame, and then input buffer would be a collection of frames. Oh man, this is getting a little mind twisty. I don't know how much we're actually gonna get done before noon. Okay, so we're gathering the input for this player, whether it's predicted or not. I'd really like to have some methods on here, but maybe let's start with not that, so I can get kind of an idea of what we need to do to it. Okay, so we get the local input, we pass off our local input, then we get to here. Where I think we want to make, so we're starting a new frame as far as the local client is concerned. So this would be like input frame equals input buffer frame new. No, so I'm storing the input buffer and the game state separately. So there is a game state buffer, which is the stored state for 20 frames back, and then the input buffer, which is also going to be for 20 frames back or whatever, but they're going to be separate because every time we roll back the game state, we want to just destroy everything that comes after. We don't need that anymore because when we're rolling forward, we're going to redo it. And with the input buffer, we're going to be sort of progressively filling in the values. So maybe on one frame, I have my input and I have player 2's input, but not player 3's input. So that's like predicted. And then on the next frame, maybe that's when we finally get player 3's input, which we bring back. And then if it differs from the predicted input, then we initiate a rollback, right? So we just kind of need to keep them separate. So, but the input buffer should just be held locally correct. Yeah. So, I mean, all of the game state and the input buffer are just held locally. The only thing that we are passing out to the other peers is whatever our individual local input was for this frame. The input buffer is going to contain everybody's input for each frame, and it's going to include not just real inputs, but predicted inputs. Yeah. And I guess we need some kind of like, so up here we're discarding like old frames from the state buffer. We're going to need to do the same for the input buffer, but we're going to need like some kind of safety hatch where if we try to discard an old frame that still has predicted input in it, that means something went terribly wrong. That will create an unreconcilable situation. So we'll need to when we get to that part, we'll need to have some logic for that. Okay, so we're creating a new input frame. In that input frame, we are putting in the input for our local player, which we know our peer ID. Do we grab it anywhere? I guess not. So here we'll do is that get tree, get, is it unique, network unique ID? And we will put an input for player on here, which will contain our local input, and it is not predicted. So let me go make a constructor that does that. Player, init is going to be okay, so we have just our local input for this input frame. Then we need to predict the input for all of the other players. And where should that method live? I'm thinking on the sync manager. Yeah, probably. And I guess we want it to repredict all input that is predicted or missing. So say predict, or no, maybe that can happen in doTick. Maybe in doTick we pass in input frame. Let's try this. And then we need to add this to our input buffer. Buffer append input frame. Or no, or we can do that in doTick also, because that's where we're doing it for the state. So that seems good to keep those two things together. doTick. Okay, so we're passing not local input, but we're passing in input frame, which is input buffer frame, which, yeah, we need to predict up front here. Okay, so how do we know what all the players are? Do we get that from online match? Or are we doing it here in peers? Oh, no, we're not, because we have a local thing of all the peers. Okay, so we're going to loop over the peers list for, hey, actually, do we know, are we storing who the local peer is in here? State, frequency, current tick. How, we have to be storing who the local peer is, right? Because how else are we calculating these advantages and stuff? Oh, okay, so we're only looking at the peer IDs when we're receiving them. When we send them, we just figure out we're sending them. Okay, cool. So for peer in peers, we're going to look at this input frame. We'll say if input frame players has, okay, so it'll be not has peer ID. If we don't have any input for a particular peer, or the input that we do have is predicted, then we're going to repredict it, because this could also be getting called in a rollback. So then we'll say input frame. Oh, but we have to get the previous frame. How do we know what the previous frame is? I guess it's at whatever frame's at the top of the input buffer, but will that be true when we're rolling back? Probably not. Okay, okay. We have to do the signature of this function differently. I guess we do want to add stuff to the input buffer right away, and then we'll maybe pass an ID to the frame. When we're rolling back, do we change what current frame is? We do. We do change what current tick is. Okay, so that'll make this easier. We don't need to pass anything in. We'll say the input frame is the input buffer. Or no, because current tick tells us the tick number, not where we are on the, oh, geez. Okay, we don't want to do this. Current tick goes back, rollback ticks. We need some kind of pointer into the input buffer for where we currently are. How do we do that? Do we need to have another integer that we're counting up? Although it's going to change. Oh my god. Okay. How do we point at which frame in the input buffer we are? We give an index, sure. It will almost always be the last index, but in the case of a rollback, we roll it down. How do we roll it back forward? I guess here's where we'll roll it back forward. And so maybe, okay, say input buffer or current input index, something like that, current input index. It will be equal to so we don't necessarily know the size of the input buffer. It's probably going to always be the max, but it won't be in the beginning. So maybe it's better to refer to this using negative indexes. So we'll say, if we roll back, okay, so we're normally on -1. If we roll back a certain number of frames, it will be minus the rollback ticks, right? And then here when we roll forward, I'm going to do current input index plus equals 1, because we're going through all of the rollback ticks. And current input index -1, because that's always going to be the last item in the input buffer. And there will always be an item in the input buffer so long as we add one here. Append put frame. All right. And then this is where we would, I guess, remove old input buffer frames. So we'll say while input buffer size is greater than max, what was it? Max state count, because yeah, we're keeping the same number of states as frames in input buffer, max state count. Then we'll do input buffer pop front. What do we call this, like retired input frame. And then here we need to make sure that it doesn't have any predicted input. Because if it does, then we're screwed. We have to abort. So say if retired input frame, we'll call it maybe is complete. This will be not is complete. Explode. How do we explode? I guess we have a stop function somewhere. Stop. I don't know how we tell an error, but we'll just add a to-do for that. Yell loudly that things are broken. Because yeah, if we never got real inputs by the time a frame was removed, then there's no way to fix that. And so somewhere, someplace, we're completely out of sync. And here we'll add that isComplete method. Func is complete. And it is complete if none of the inputs are missing or predicted. So we'll start by saying complete true. Then we'll do for. We need to know who are the peers. So I guess we have to pass in the peers. For peer in peers. If not, or no, we don't even need to keep this. This can be even simpler. If not players has peer is index, no, peer ID. Or players peer peer ID predicted, then return false. Frame is not complete, otherwise return true. Yay, no more red. And I have to go back here, fix. Okay. I have no idea what I was thinking there. I'll come back to that later. What I know I need to do here is that isComplete needs to have the peers passed in. Okay. So we've added an input buffer frame. Cool. Now we're jumping to doTick, which doesn't need to take the input frame because we're using that index. Oh, okay, that's where this is coming in. So input, it was current input index. Okay, so that's the current frame, and then we need to get the previous frame, which I hope is there. Previous frame. Yeah, because I can't just do current input index -1 because maybe there isn't a frame there. How do I check that with relative indexes here? Previous input index is current input index -1, and then I gotta say if, oops, typos galore. If previous input index, okay, if the absolute value of the previous index is less than, so -1 will work if the size is 1. -2 will work if the size is 2, but not if the size is 1. So if the absolute value is greater than the input, or no, less than, because we want less than or equal to, because we want the success case, right? Is less than or equal to input buffer size. And I guess we can do this like this. If that, else null. Okay, so we get a previous frame if one exists, otherwise it's null. And then this we actually don't need to do, or no, we do need to do because we need to go over each one. I was hoping I could reuse that isComplete function, but we can't. Okay, so if we don't have it or the input is predicted, then and we can only really do this if we have a previous frame. So if previous frame, or no, okay, we'll just inject empty predicted values if we don't have a previous frame. So we'll say if previous frame, then input frame players peer ID equals predict input for the previous input, so previous frame players peer ID. Otherwise, we just set players peer ID, and this is actually, hang on, that's wrong too. These need to both predicted input dictionary. These both need to assign to predicted input. Oh, actually it doesn't need to because an empty dictionary is an empty dictionary. Yeah, okay. I'll do that. And then input frame players peer ID equals, then we need to make a new input for player class with this predicted input. and true. Okay. Does that seem sane? Wait, why is too few arguments for gather local input? What are you complaining at me here? Is that an old thing? That might be an old message from when the game was running. Okay. Input frame, local players, blah, 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 predicted inputs. Okay, so this predicts the old inputs. And what we need to pass to network process is the full frame, because we want the input for all players. So input frame. Yep. Expected at most 1. Pass in, I guess we'll put frame here. And we need to jump back to our player, where we are now getting input frame. And rather than grabbing the data from here, we need to grab it from the input frame. For that, we need to know what peer we are, which we do actually know. Okay, that was a good choice using the peer ID, because we know what it is, because it's set on the node. So then var vector equals input frame players get network master. Hang on. We'll do this different. We'll say input equals this input, right? Sync manager. Way up at the top, our input frame. Input frame has input for players, which has input. Okay, so then we should end up with the dictionary that we gathered input for, which just has a really nice input vector here. And the just pressed comes from input, is it is attacking or attack pressed? I'll go look at it in a second. I just want to have something here. Attack pressed. Okay. Wow. Okay, so we're going to keep sending these remote player updates, which is from the old networking model. We'll remove it eventually. But for now, we just want to ensure that our input gathering is actually working in some remote way. Come on. And we crashed. All right. Is complete. Convert arguments from dictionary to array. Oh, okay, because peers is an array, not a dictionary. That was a type problem here. Is complete array. Oh, peers. So how are we doing this for peer and peers junk if this is a dictionary? And what? For peer ID in peers. Okay. I messed this up in a couple of places then. So for peer ID in peers, we say var peer equals peers peer ID. And for peer in peers values, oh, actually, that's a better way to do this. For peer in peers values. Unless we only use the peer ID here. We only use the peer ID here. Okay. Is that good? All right. So for peer and peers values, peer ID and peers, for peer ID and peers, for peer and peers. All right. So this one also can be just peer ID. Cool. Peers is a dictionary. Okay, try again. Anything working? Nope, nothing's working. All right, so, oh, you know what? Or no, we don't need to increment it because -1 will always work theoretically. I was about to say maybe we're not incrementing that input frame index. All right, we will get to where we process local input and make the input frames. Start there. So, set a breakpoint, got the breakpoint right away. Going to step over, see what local input contains. Nothing's pressed because I ain't pressing nothing. But the values are there, so that's good. As a dictionary, that's really the best we can do. Why didn't we send this to any of the peers? That's weird. Not a problem right now, though. So we're filling up input frame. Let me look at this input frame. It has a players dictionary, which contains just ourselves with these values. That looks good. It's greater than max state count. The size is greater than max state count? That doesn't make sense. Max state count is 20. Oh, okay, yeah, because we're stopped in the middle. I'm imagining I'd like just pressed run on the program. So of course, yeah, it's always going to be higher than it because we already filled it up to 20. So let's remove this one. Now we're going to do a tick. We're going to do step into. Then we get the current input frame. Input frame, which has our player with this input. That's good. Previous frame, let's make sure that the logic I wrote before earlier works. Previous frame. Yep, there's an existing previous frame, so that's good. Then we loop over the peers, which does nothing. Why are there no peers? Did we forget to add the peers? I think we probably did. Okay, well that shouldn't matter here either though, because all we're trying to look to see is that the input got added. So let me jump over to here. So we're player controlled, which actually we don't need to check player controlled anymore. That's no longer a thing. Let's get rid of that. And now I've totally screwed up the way these line up. I'll just put an extra new line there so they still line up the right way. And we're stepping over. We get an input vector that is empty, right. Move and collide on the vector. Is attacking. No, this is right, because this will only do it when it's just pressed, so it'll start it. Okay, that's good. And then updating the remote position, all that. Okay, so why is it not responding to my input here? Let's go to Game Sync Manager. I guess we don't know if the input vector is ever not 0. Let's just add a little debug statement here. If input vector is not equal vector to 0, then we'll print it out. Okay, we will stop and start again. And what do we got? We got some kind of error here? Or no, breakpoint. Okay, forget that breakpoint. Continue. Carry on. Oh, another breakpoint that I forgot to remove. Go. Carry on. Is the game still running or did it crash? get index 2 on base dictionary. Oh. Yeah, this is because we are not adding the peers, so we're not actually predicting the input for the peers. I guess we should do that. Okay, so sync manager needs to be initialized with a list of the peers, and that I guess should happen in game when we are first starting. I guess in game setup. We're creating the players, which is good. We also need to add the, so if not online play, if we are in online play, is it adding our player in a different way than the normal player? Peer ID and players. No, this should, yeah, this should be good. This should be good. So sync manager, add app, add peer. And how did that look? Sync manager adds a peer. The constructor for a peer just takes the peer ID. Perfect. Nice and simple. And then I am going to need to put this in the class DB so I can refer to its inner classes here with the peer ID. Okay, starting all over. What did I do wrong this time? Oh, I was not thinking in GDScript. I was thinking in Python or something. Okay. And this time, add peer cannot convert. Well, oh. So we're not actually creating we're not actually adding the class. We're just adding the integer. So I didn't, whatever. Moving too fast here. Need to read my own code a little better. Come on, let's get something that moves. Record advantage expects one argument, got no arguments. What's the argument for record advantage? Oh, ticks to calculate average. Okay. So where are you? Record advantage. Okay. Wow. This is the stage where everything breaks because I didn't test my old code very much. Okay, so it needs to be calculated advantage, not advantage. This is code I wrote last week when I was integrating the code from that demo that was synchronizing the tick numbers that I did not fully test because I guess I had forgotten to add the peers to the object. Kind of skipping all of that anyway. Input for player, not init. It's new. Right, that's the input predictions. We're getting to code that we just wrote now. We're moving forward in time here. We're almost to testing this for real. Come on. No input vector. Oh, okay, because it might not have any input. Right. Because in the first bunch of frames, it can't even predict. So we're just going to say, if we can't get it, there is no input vector, and same for this one. We'll try and get attack pressed. If there is no attack pressed, then we didn't press it. All right. That input prediction code we wrote a little bit ago. finely executed. Predict input in base node. Predict input, predict input. Oh, from object to dictionary. Oh, because we're passing the whole frame. We don't want that. We want the input dictionary. All right. Again, bugs in that input prediction code we wrote. Getting closer, closer, and closer. Oh my god. Invalid index -1. But -1 should always be valid when I just added something. I just added something. Input buffer, size 0. How can it be size 0? We add a frame here, and then we do tick. I mean, I guess here we remove things if the size is greater than the... Okay, well, let's restart, go to a breakpoint there. I'm sorry, guys. I'm sorry this isn't more exciting. We might get to a point where where we're buffering input, we're buffering states, but we might not be actually doing any rollback. We only have like 5 more minutes. Okay, so we are adding the first bit of input to the input buffer. So input buffer is got an array size of 0. We'll step over this line. Input buffer should now have size 1. That should not do anything. Should step into an input buffer current input index -1. That should give us just the first item, which it does. That's cool, right? Previous frame index. Oh, hang on. Don't need to do this again. Let's do previous frame index. Previous input index. Okay, and then we loop over the peers. We're going to predict their input. How do we end up in a situation where there's no... I'm just going to keep watching the input buffer here. Size 1, size 2, size 3, size 4, size 5, size 6, size 7, size 8, size 9, size 10. So it's doing things. It's filling up till 20. And then it strangely empties all the values out. Oh, you know what? It's this thing here that we added because we're never putting in the real inputs, so it's always dying there. That's totally what it is. That's totally what it is. Let's try this again. That failsafe will be very important once the system is actually working in some remote way. But until then, we just need to let it fill up with bad predicted inputs. Oh, come on! Why isn't it working? What is happening here? It's never gathering input. Why are you never gathering input? Oh my god, this might be the most anticlimactic stream ever streamed in the history of game dev streaming. What's the debugger yelling at me for, though? That's interesting. Let's go see. Maybe that'll be a hint. Has no current animation. Okay, that's interesting. So that'll need to be fixed, but that doesn't matter. Not for why this isn't working. I don't know, guys. I don't know. The input should be coming in. It just never is. So this is going to the right thing, right? To our gather local input here. Gather local input is the right method. It's returning a value, which it has to because return value is marked there. We're never getting input. Oh, bam. String identifier gone awry. Come on. You can do it, demo. You can end us on a high note of something actually happening. Ah ha 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 ha. Here we go. Okay. I don't know why D isn't working. WASD. So W is not working. S is working. What is happening? W works sometimes, but not all of the times. It's a sometimes W situation. Does attacking work? Attacking doesn't work either. Oh my god. What's happening here? Input prefix, player, blah, up, down, left, right. Almost ended on a high note. Almost did it. Oh my god. Well, what can I say? You win some, you lose some. Is anyone still even watching? Ah, there's some people watching. Well, so we got part of the way here. We have, I believe it's saving state correctly. We never got a chance to test that it was loading the state correctly. We know that there's some issues in the way that it's saving state because this is causing a whole bunch of debugger warnings by setting these when there's no actual animation playing. That's easy enough to fix. We have it making an input buffer that has some signs of maybe working somewhat, maybe predicting somewhat. We have the input gathering seems to work sometimes, but not all of the times. I'm not entirely sure why. Thanks, guys. Thanks, Damon. Thanks, Elliot. Yeah, it was an interesting thing to think through. I don't know. What do you guys think? Do you think I should save this for the next stream so that you guys can pick up with me, or should I try to advance it further in the meantime, and then we can do something a little bit more interesting next Friday? I'm kind of two minds about that. If I work on it on my own, like probably, another 2 hours and I'll have it working, which, then will be more interesting to look at, but then you guys won't get to learn along with me. I guess I don't know. It's a horse apiece. In any case, thanks so much, guys. Thanks for hanging out and working through this with me. Thomas, I'm sorry we didn't actually get around to checking, the thing with animation player, if seek or advance will do more of what we want. I will definitely, put somewhere, whether on Twitter or Discord or in YouTube, kind of the results of that if I do manage to see which one is the correct one. Elliot doesn't care. Damon just wants to see what the answer was. Yeah, okay. Yeah, maybe we'll do it that way. I'll work on it, over the next week, and then I'll start the next stream by showing, what it took to get it working and what the problem was, and we can get into maybe some more interesting stuff. There is a whole bunch of more interesting stuff to dig into. I think that we're going to run into some problems with the Godot physics engine and might end up having to hack Godot to add some methods that we need. We'll see. But yeah, again, thanks so much, guys. Thanks for watching. I had fun. I hope you have fun. and I'll see you next week. Bye-bye.